Welcome students. So in this video we will be solving biquadratic equations. Okay, biquadratic equations. See, biquadratic equations we will be using Ferrari method. Okay, so what is a biquadratic equation? It's an equation, a polynomial of degree 4, and the coefficient of the highest term is 1. Okay, this is the equation we are considering. So now Ferrari is trying to simplify the equation. So he took the terms x square containing x square, x, and also the constant term to the other side. Now the equation will look like this. We will be trying to make squares on both sides. Okay, we will have to add some terms in this equation so that the both sides will be a square. After that we can, if this is a, then a square, this is b square. We can cancel this and get a is equal to either plus b or a is equal to minus b, right? X square is equal to 4 implies x is equal to plus or minus 2. Similarly, we will get two equations. Okay, and here these in our concept, these equations, we will get two equations where they will be quadratic equations. That is, this biquadratic equation, we will add some terms to both sides and get a perfect squares at both sides. After that, after cancelling the roots, we will get quadratic equations which we can solve using quadratic formula. Okay, so first we will add x square by 4, sorry, a square by 4 into x square. Okay, hold a second. Let me put this. Yeah. So how are we? Why are we adding this term? Because we have this x. I am rewriting these terms as x square whole square plus 2 into x square into ax by 2. Okay, this is nothing but 2 gets cancelled, and this is x cube only. Same thing. So comparing, see, this is like a square plus 2ab plus, right? Now if you want to make this into a whole square, we will have to add that b square. So b is this, so we will have to add the square of this, that is a square x square by 4. That is what we are adding here. So when we are adding this, we will add that to the both sides. So this is the perfect square, and here we combine the coefficients with containing a term of x square. So we have this. Okay, now in the equation 1 we have to make this side also a perfect square. Okay, and also this portion. Okay, this portion should. Okay, so we will have to add some things to this LHS, also this this RHS, and also this should still remain a perfect square. Okay, so we are adding this term to both sides, and we can see that you don't have to study the method, but just understand them. Okay, so we are adding something to the both sides so that this side is again a perfect square, and we will get here something like this. Okay, we combined all the x square terms and x terms and the constant. This equation 2 is very important. This is the only equation you will have to study. Okay. Now LHS is a perfect square. Now what about the RHS? What about the RHS? Yeah, so I am highlighting this equation. You will have to study. Okay, so yeah, so consider now this is a perfect square, right? So let us forget about that for now. Now here this is an expression, it's a quadratic equation, right? If we take this term as A, this term as B, and this term as C, we are having ax square plus bx plus c. When will we get this as a perfect square? If we can factorize this into product of roots, right? X minus 1 root into x minus other root, right? So when these roots are same, we can like make it into a perfect square. See? Okay, so the question is, when will the quadratic equation have same roots or equal roots? Just pause the video and think. Okay, very good. We'll have when the b square is equal to minus 4ac is equal to 0, that is discriminant equal to 0, we will have that equal roots, right? So from here we will have b square is equal to 4ac. You know what is b square? See, this is the b, so square that. And for a, you know, this is the a and this is the c. So you substitute that and you will get something like this. Okay, when this is satisfied, okay, in this equation we will be having y. So expanding though, we will get a cubic equation. This cubic equation is called the resolvent of the biquadratic equation. Resolvent of the biquadratic equation. Okay. Now, how can we solve a cubic equation? We have already learned Cardan's method. Okay, but for exam, so most probably these equations will be having roots, smaller roots like 0 or plus or minus 1 or maybe plus or minus 2, maybe plus or minus 3 or maybe half. So you can use trial and error method. Trial and error method. What is that? You put this value into this y. If you are getting 0, then that is a root. Okay. So like that you will have to try. After, if this doesn't work, then you can use Cardan's work. Okay. Okay. So you will get some y is equal to some value. Okay, this is a root. Okay, you will definitely get, because cubic equation will have at least one rational root, and we have to put that value in this expression 2. The equation 2 is very important, as I said. So in equation 2 we will put the value of y. Okay. So this value of y satisfies the condition b square equal to 4ac, and hence we can write it into a perfect square. See, this is an example of a perfect square. Okay, so in LHS is already a perfect square. In equation 2, LHS is already a perfect square, and this side is again a perfect square. So like I said, when we cancel this roots square, we will get what? Plus or minus. So this is the first equation, quadratic equation. This is the second quadratic equations, and we will solve by quadratic formula. Okay, so it is easy, right? Now you don't have to learn all the steps, but you will have to understand the steps, right? You will have to learn the equation 2, so you will get what is in the LHS side as well as in the what is A, B, C. Now you will have to use b square minus 4 is equal to 0 or b square is equal to 4ac. From here you will get a cubic equation, that is the resolvent. From there you will have to put value, find the value of y, substitute to this, we will get a perfect square in both sides, and after that you can solve easily. Okay, so let us consider an example. Okay, let me rub this. Okay, so this equation, this is a biquadratic equation. Now x raised to 4 plus 0 x cube plus 0 x square plus c, that is 4x minus 1 equal to 0. So this is a, this is b, this is c, and this is d. So a is 0, b is 0, c is 4, d is minus 1. If we are putting that in the equation 2, okay, in the equation 2, what you will get? This term will be 0, these terms will be 0, these terms will be 0. Why? Because a is 0, here b is 0, a is 0, here again a is 0. So you will have, in the RHS side, you will be having yx cube minus 4x plus 1 plus 1 by 4 by square. So what is a? This is a, this is b, this is c. So in formula, b square minus 4ac equal to 0 or b square is equal to 4ac. When we put that values, you will get 16 is equal to 4 into y into 1 minus 1 by 1 plus 1 by 4 y square. Okay, solving this, you will get expression y cube. Let me see what we will get. Yeah, we will get y cube plus 4y plus 16. So this is what the resolvent, cubic resolvent. By trial and error method, we will get y is equal to 2 as a solution. Okay, you got your y. You know what? Go back to the equation 2. Okay, equation 2, here this term was x square plus y by 2 whole square. So consider this equation, put the value y equal to for everywhere where y is there. So what you will get? You will get x square plus 1 whole square is equal to 2x cube, this is square, sorry, 2x square, 2x square minus 4x plus 2. So this can be written as root 2 square into x minus 1 whole square. Okay, take 2 common outside and try. So this is nothing but root 2 into x minus 1 whole square, which is written as like this. Okay, so we have squares on both sides. X square plus 1 whole square is equal to root 2x minus root 2 whole square. So we will get two equations that are what we will have these two equations. Okay, these two equations you can solve and get the answer. Okay, now the example 2, I haven't done the solution. We'll form a biquadratic equation from this question. Okay, please read the question. Okay, so this point is a comma a, and this distance is x, this distance is y, and this length is l. Okay, so this is a what intercept, x intercept, this is y intercept. So this is x comma 0, and this is 0 comma y. So we have already learned what is intercept form in lower classes, right? So this is the equation for intercept form. So this is the equation of this line, and this point P is on the line, so we can it satisfies this equation. So this will be written as ax plus ay equal to 1. So this is nothing but ay plus ax equal to xy, and ay is equal to xy minus ax, and y is equal to x. Yeah, we have to make this as y is equal to. So what we'll do, this step is not needed. We'll take ay minus xy is equal to ax, take y common. So a minus x is equal to ax, so y is equal to ax by a minus x. This you will have to put it in the equation. Y square plus x square is equal to L square. We'll put this y here. So where did this equation come? We can use Pythagoras theorem. Clear? So this will turn into a biquadratic equation. Okay, from which you can solve the answer. See, this is a biquadratic equation which you will get. Okay, so we'll end this video here. Okay, please make a note of this video and do more problems. Okay, thank you.